The of the natural philosopher is to construct theories which will save appearances. Most of us first meet this expression in Paradise Lost, and most of us perhaps originally misunderstood it. Milton is translating sosein ta phenomena, first used so far as we know by Simplicius in his commentary on the Aristotelian De Caelo. A scientific theory must save or preserve the appearances, the phenomena it deals with, in the sense of getting them all in, doing justice to them. Thus, for example, your phenomena are luminous points in the night sky, which exhibit such and such movements in relation to one another and in relation to an observer at a particular point, or various chosen points on the surface of the Earth. Your astronomical theory will be a supposal such that, if it were true, the apparent motions from the point or points of observation would be those you have actually observed. The theory will then have got in, or saved, the appearances. But if we demanded no more than that from a theory, science would be impossible, for a lively inventive faculty could devise a good many different supposals which would equally save the phenomena. We have therefore had to supplement the canon of saving the phenomena by another canon, first perhaps formulated with full clarity by Occam. According to this second canon, we must accept, provisionally, not any theory which saves the phenomena, but that theory which does so with the fewest possible assumptions. Thus, the two theories, A, that the bad bits in Shakespeare were all put in by adapters, and B, that Shakespeare wrote them when he was not at his best, will equally save the appearances. But we already know that there was such a person as Shakespeare, and that writers are not always at their best. If scholarship hopes ever to achieve the steady progress of the sciences, we must therefore provisionally accept the second theory. If we can explain the bad bits without the assumption of an adapter, we must. In every age, it will be apparent to accurate thinkers that scientific theories, being arrived at in the way I have described, are never statements of fact. That stars appear to move in such and such ways, or that substances behave thus and thus in the laboratory, these are statements of fact. The astronomical or chemical theory can never be more than provisional. It will have to be abandoned if a more ingenious person thinks of a supposal which would save the observed phenomena with still fewer assumptions, or if we discover new phenomena which it cannot save at all. This would, I believe, be recognized by all thoughtful scientists today. It was recognized by Newton if, as I am told, he wrote not, "The attraction varies inversely as the square of the distance," but "all happens as if it so varied." It was certainly recognized in the Middle Ages. In astronomy, says Aquinas, an account is given of eccentrics and epicycles, on the ground that if their assumption is made, hac positione facta, the sensible appearances as regards celestial motions can be saved. But this is not a strict proof, sufficienter probans, since for all we know, forte, they could also be saved by some different assumption. The real reason why Copernicus raised no ripple and Galileo raised a storm may well be that whereas the one offered a new supposal about celestial motions, the other insisted on treating this supposal as fact. If so, the real revolution consisted not in a new theory of the heavens, but in a new theory of the nature of theory. On the highest level, then, the model was recognized as provisional. What we should like to know is how far down the intellectual scale this cautious view extended. In our age, I think it would be fair to say that the ease with which a scientific theory assumes the dignity and rigidity of fact varies inversely with the individual's scientific education. In discussion with wholly uneducated audiences, I have sometimes found matter which real scientists would regard as highly speculative more firmly believed than many things within our real knowledge. The popular imago of the caveman ranked as hard fact, and the life of Caesar or Napoleon as doubtful rumour. We must not, however, hastily assume that the situation was quite the same in the Middle Ages. The mass media, which have in our time created a popular scientism, a caricature of the true sciences, did not then exist. The ignorant were more aware of their ignorance then than now. Yet I get the impression that when the poets use motives from the model, they are not aware, as Aquinas was, of its modest epistemological status. I do not mean that they have raised the question he raises and answered it differently. More probably, it has never been before their minds. They would have felt that the responsibility for their cosmological or for their historical or religious beliefs rested on others. It was enough for them that they were following good auteurs, great clerks, this olde wise. Not only epistemologically but also emotionally, the model probably meant less to the great thinkers than to the poets. This, I believe, must be so in all ages. Quasi-religious responses to the hypostatized abstraction life are to be sought in Shaw or Wells, or in a highly poetical philosopher such as Bergson, not in the papers and lectures of biologists. Delight in the medieval model is expressed by Dante or Jean de Meung, rather than by Albertus and Aquinas. Partly, no doubt, this is because expression of whatever emotion is not the business of philosophers. But I suspect this is not the whole story. It is not in the nature of things that great thinkers should take much interest in models. They have more difficult and more controversial matters in hand. Every model is a construct of answered questions. The expert is engaged either in raising new questions or in giving new answers to old ones. When he is doing the first, the old agreed model is of no interest to him. When he is doing the second, he is beginning an operation which will finally destroy the old model altogether. One particular class of experts, the great spiritual writers, ignore the model almost completely. We need to know something about the model if we are to read Chaucer, but we can neglect it when we are reading St. Bernard, or the Scale of Perfection, or the Imitation. This is partly because these spiritual books are entirely practical, like medical books. A man concerned about the state of his soul will not usually be much helped by thinking about the spheres or the structure of the atom. But perhaps there was in the Middle Ages another factor also at work. Their cosmology and their religion were not such easy bedfellows as might be supposed. At first, we may fail to notice this, for the cosmology appears to us, in its firmly theistic basis and its ready welcome to the supernatural, to be eminently religious. And so in one sense it is. But it is not eminently Christian. The pagan elements embedded in it involved a conception of God and of man's place in the universe which, if not in logical contradiction to Christianity, were subtly out of harmony with it. There was no direct conflict between religion and science of the 19th century type, but there was an incompatibility of temperament. Delighted contemplation of the model and intense religious feeling of a specifically Christian character are seldom fused except in the work of Dante. One difference between describing the model and writing a history of thought has been